Differentiation of inverse trigonometric functions. So there's a number of different rules for differentiating inverse trigonometric functions. So we're going to detail these below with the associated proofs. So differential here of our inverse sine of x becomes 1 over 1 minus x squared. So for our proof we're saying y is equal to our inverse sine of x. So x is equal to sine of y. So here we can differentiate x with respect to y is equal to cosine of x. So dy on dx is 1 divided by dx on dy. So we're inversing this. Here is 1 over cosine of y here. And here we've got sine squared of y plus cosine squared of y is equal to 1. So here cosine squared y is equal to 1 minus sine squared y. Cosine of y is equal to 1 minus sine squared of y. And so we substitute this in here, and therefore dy on dx is equal to 1 divided by 1 minus x squared. And hence here our differential of our inverse sine of u is equal to 1 over the square root of 1 minus u squared du on dx. And here we have our u is between -1 and 1. So here we also have our differential here, inverse sine of x here of x divided by a is here 1, drag that up here, there we go, 1 divided by here square root of a squared minus x squared. So moving on in our proofs here, we end up with our second proof here. Our differential here of our inverse cosine of u is 1 over the square root of 1 minus u squared du on dx, again with u between -1 and 1. So we go through our proof as before. Y is equal to cosine or inverse cosine of x, so x is equal to cosine of y. So here we differentiate x with respect to y, we get negative sine of x, and then we invert to find dy on dx. Here is 1 over negative sine of y. Using here our sine squared y plus cosine squared y is equal to 1. So here sine of y, this should be, so sine squared y is 1 minus cosine squared y. Sine of y is equal to the square root of 1 minus cosine squared y. So substituting into that, here we're going sine of y is equal to 1 minus x squared. So here our dy on dx is -1 on the square root of 1 minus x squared here. And again with our fraction, here our differential of our inverse cosine of x divided by a becomes 1 divided by the square root of a squared minus x squared. And here with our tan function here, so our inverse tan of u differential here is 1 over 1 plus u squared du on dx, again with u between -1 and 1. So here to prove, we're saying y is equal to our inverse tan of x. So we switch that around, x is equal to tan of y. We differentiate x with respect to y here, and we get 1, for both sides 1 is equal to sec squared y dy on dx. Here, so dy on dx is equal to 1 over sec squared of y. And we know sine squared plus cosine squared y equals 1. Dividing by our cosine squared here, we get sec squared y is 1 plus tan squared y. So dy on dx is 1 divided by 1 plus tan squared y, becomes 1 on 1 plus x squared. So here our differential of our inverse tan of u is equal to 1 over 1 plus u squared du on dx. And again with our fractional, here our inverse tan of x over a becomes a divided by the square root of a squared plus x squared here. So now working through to using these formulas here. So we want to find the first derivative of the following here. We're going to start by writing out our rule here. D on dx here, inverse cosine of u is equal to 1 on the square root of 1 minus u squared du on dx there. So now we come back to our formula. So our u is equal to 2x. Du on dx is therefore equal to 2. So dy on dx here is equal to 1 over the square root of 1 minus u squared, 2x squared, multiplied by du on dx is 2. Becomes 2 over the square root of 1 minus 4x squared here. So moving to our second example here, we'll start again by writing out our formula here. So we say d on dx, we have our tan function here. Our inverse tan of u is equal to 1 on 1 plus u squared du on dx. So here our u is equal to e to the power of x. So du on dx is also equal to e to the power of x. So here dy on dx is equal to here 1 over 1 plus u squared. So here e to the power of x squared multiplied by our du on dx. Here is e to the power of x. So this becomes e to the power of x divided by 1 plus e to the power of x squared. Moving to our next example here, we'll start again by writing out our formula here. We've got d on dx of inverse sine of u is equal to 1 on the square root of 1 minus u squared du on dx here. And we notice that there is a little bit of an issue here. This should actually be sine minus 1 of root 3x, separate, not root 3x, it's root 3 multiplied by x here. So now u is equal to root 3 multiplied by x here. So here du on dx will end up being root 3. So we go through dy on dx is equal to 1 on square root of 1 minus u squared becomes root 3x squared multiplied by du on dx is root 3. So here we have root 3 divided by square root of 1 minus root 3 squared is 3x squared here. And on to our last example here, and we look at this one's a little bit more of a complicated question. We'll start by writing our formula at the top to refer to. So d on dx of our inverse sine of u is equal to 1 minus square root of 1 minus u squared du on dx here. So when we look at this, we're saying, well, dy on dx, here I've got x times our inverse sine of x. So we'll start with this part of our problem. So it's going to be x multiplied by here our differential of inverse sine of x plus inverse sine of x multiplied by our differential here of x. Then we've got this second part of it here, so we're going to be here differentiating here, and so it's our square root, so it's here 1 minus x squared to the power of a half. So here we get x multiplied by here we're differentiating our inverse sine of x. So 1 over the square root of 1 minus x squared, and our u is equal to x, du on dx is equal to 1, plus inverse sine of x, and here differentiating x we get 1, plus here. So here we end up with a half, 1 minus x squared to the minus a half, multiplied by here we differentiate 1 minus x squared is minus 2x. So we end up with x over the square root of 1 minus x squared, plus here's inverse sine of x. We'll just fix that one up so it looks more like a 1. So inverse sine of x, plus here we're saying, well, it's a half, so 1 at the top, 2 at the bottom, square root of 1 minus x squared multiplied by minus 2x. So here we'll take our 1 out, multiplied by minus 2x, so we get minus 2x at the top here. We can cancel our 2's, and we have x divided by 1 minus x squared minus x divided by 1 minus x squared here. So these are going to cancel each other out, and we're left with just our inverse sine of x.